In this video, I'm going to talk about indeterminate form of limits. When finding the value of limit of a function, if limit of f(x) as x approaches a is equal to k, then we say that k is the value of the limit of the function f(x). If limit of f(x) as x approaches a is equal to positive or negative infinity, then we say that the limit of f(x) does not exist. And if limit of function f(x) as x approaches a is undefined, so same thing, we will say that the limit of the function f(x) does not exist. But sometimes when finding the value of the limit of a function, we found that the value is 0 over 0. So what is the value of 0 over 0? Is that equal to 0? No, it is not the correct answer. And maybe some of you will say that, is that equal to undefined? No, it is wrong also. And actually, when 0 over 0 for the value of limit, we call it as indeterminate form of limit. So, indeterminate form of limit means the value of the limit is uncertain, and we should use other method to find the correct value of the limit. And same thing, when we find the value of limit, sometimes we can come to the answer that the answer is infinity over infinity. So what is the value of infinity over infinity? Is that equal to 1? No, it is not the correct answer. And is that equal to infinity? No, it is not the correct answer too. And actually, infinity over infinity, it is another form of indeterminate of limit, and means the value of the limit is uncertain, and we should use other method to find the correct answer for the limit. Actually, for indeterminate form of limit, other than 0 over 0 and infinity over infinity, actually there are some other indeterminate form of limit. For example, infinity minus infinity also is another indeterminate form of limit. Infinity multiplies 0, 0 power 0, infinity power 0, and 1 power infinity. These are, we call it as indeterminate form of limit. But in this video, I will be focusing in 0 over 0 and infinity over infinity. Now let's try this question. Find the limit of this function as x approaches infinity. So first of all, when I try to substitute x with infinity, I found that the answer is infinity over infinity. So this is the indeterminate form of the limit. So means I'm going to use other method to find the limit. Now actually there are many methods can be used to find the limit of this function. First method, I'm going to factorize the denominator by using this formula, where a squared is x and b squared is 9. So when I factorize the denominator, I'll get something like this. So notice that one of the factor can be cancelled off, that is square root of x minus 3. So when I cancel off this factor, I'll get 1 over square root of x plus 3. Then I substitute the infinity for the second time. I found that it is 1 over infinity. Then 1 over infinity is equal to 0. So 0 is the limit of this function. Then followed by I try to use another method. This time I'm going to divide each term in this function with the highest power of x of the denominator, that is x. That is, I try to divide each term with x. So when I simplify, I get this one, x divided by x is 1. For square root of x divided by x, since x is square root of x times square root of x, so when I cancel off square root of x of the numerator and 1 of the square root of x of the denominator, then I'll get 1 over square root of x. Then I substitute the infinity for the second time. It is 0 minus 0 over 1 minus 0, so the answer is 0. Then for third method, now here the third method I can use the third conjugate. Notice that square root of x minus 3 is conjugate with square root of x plus 3. So I multiply the function with the conjugate third. So then I try to simplify. Then after simplifying, I'll get something like this. So notice that when you simplify, do not expand the denominator. So when you expand the numerator and you simplify, you get x minus 9. So now I notice that x minus 9 can be cancelled off. So when I cancel off, I'll get 1 over square root of x plus 3. So now I substitute the infinity for the second time. I find that it is 1 over infinity and it is equal to 0. Now method number 4, I'm going to use L'Hopital's rule. So when using the L'Hopital's rule, so students remember, please write down the formula of the L'Hopital's rule. So this is the formula of the L'Hopital's rule. So when using L'Hopital's rule to find the limit, I'm going to find the derivative of the numerator and the denominator separately. To find the derivative of square root of x minus 3, since square root of x is x power 1 over 2, then to find the derivative, first I put down the power 1 over 2 in front. Then 1 over 2 minus 1 is equal to negative 1 over 2. X power negative 1 over 2 is equal to 1 over square root of x. And the derivative of x minus 9 is equal to 1. So after derive the numerator and the denominator, I'll get something like this. And since the denominator is equal to 1, so when I simplify, I get 1 over 2 square root of x. Then I substitute x for the second time. Then I'll get 1 over infinity, and 1 over infinity is equal to 0. So these are the methods that you can use to find the limit. So next, we try to find the limit of the same function, but now I am going to find the limit as x approaches 9. So first, I'm going to substitute x with 9. So when I substitute x with 9, I find that the answer is 0 over 0. This is another type of indeterminate form of limit. So means I'm going to use other method to help to find the limit. First method, I'm going to factorize the denominator. Then I cancel off square root of x minus 3. And finally, I substitute the x with 9 for the second time. I find that the answer is 1 over 6. So 1 over 6 is the value of the limit of this function as x approaches 9. Then for the second method, divided each term with the highest power of the denominator, actually it is not suitable to find the limit of function to a point. This method is suitable for finding the limit of a function to infinity. So, for the second method, I am going to use the conjugate set. So, I am going to multiply the function with the conjugate set square root of x plus 3. So, when simplified and I cancel off x minus 9, then I substitute the x for the second time. Then I find that the answer is equal to 1 over 6. For the third method, now same thing, I'm going to use the L'Hopital's rule. Remember students, if you want to use L'Hopital's rule, you must write down the formula here. Then, to use L'Hopital's rule, you need to derive the numerator and the denominator. So, the derivative of square root of x minus 3 is equal to 1 over 2 square root of x, and the derivative of x minus 9 is 1. So, when I simplify and I substitute the x with 9 for the second time, then I'll get the answer 1 over 6. Now let's try this question. Find the limit of this function as x approaches infinity. First of all, when I substitute x with infinity, I find that the answer is infinity over infinity. It is one of the indeterminate form of limit. So, means I'm going to use other method. So, first method, I'm going to factorize the x power 2 under the symbol of square root. So, when I take out x power 2, I'll get 1 minus 3 over x power 2. Then, I separate this x power 2 and the brackets becomes like this. Because we have learned that square root of mn, I can separate becomes square root of m multiplied with square root of n. So, this one, square root of x power 2 times the bracket can be separate, becomes square root of x power 2 times square root of this expression. Then for square root of x power 2, we know that square root of x power 2 actually is equal to modulus x. Modulus x can be equal to positive x or negative x. Positive x is when x is positive value, negative x is when x is a negative value. Since in this question we are going to find the limit as x approaches to positive infinity, so means x is a positive. So means square root of x power 2 actually is equal to positive x. So after that, notice that x of the denominator and x of the numerator can be cancelled off. After simplify, then I substitute the x with infinity for the second time. So 3 over infinity is equal to 0. So finally, the answer is equal to 8. Now for the second method, I'm going to divide each term in this function with the highest power of x of the denominator. Notice that the highest power of the denominator, it seems like it is x power 2. But actually, x power 2 is under the square root. So we know that square root of x power 2 is x. So actually, the highest power of the denominator is x. So therefore, I divide each term in this function with x. Then, for 8x and x and x can be cancelled, becomes 8. For this one, before I can cancel x with x power 2, I must change x becomes square root, because x power 2 here is under square root. And same thing, we know that if we want to change x to square root, It depends on x is a positive or negative. If x is a positive, where x approaches positive infinity, means x is equal to positive square root of x power 2. If x is a negative, means when x approaches negative infinity, means x is equal to negative square root of x power 2. Since this question, we are going to find the limit as x approaches positive infinity. So means when x is equal to square root of x power 2. So we change x becomes positive square root of x power 2. Then after that, we combine this square root becomes square root of x power 2 minus 3 over x squared. Because I'm using the index concept where square root of m divided by n is equal to square root of m divided by square root of n. So now when I simplify this part, I'll get something like this. So now I substitute the value of x for the second time with infinity. So 3 over infinity is equal to 0. So finally the answer is 8. Now for this question, actually conjugate set is not suitable. And same thing, L'Hopital's rule is not suitable too, because the process of differentiation involving square root of x power 2 minus 3 will create an endless process of differentiation. Now we go to the next question. Now this question, the function is the same, but now this question I'm going to find the limit as x approaches negative infinity. So the first method, when I factorize the x power 2 and separate the square root of x power 2, to change square root of x power 2, notice that now x approaches negative infinity. As x approaches negative infinity, so means square root of x power 2 actually is equal to negative x. So I changed square root of x power 2 becomes negative x. Then I cancel the x on the numerator and denominator, and I bring up the negative to the numerator. Then I substitute the x with the negative infinity. I find that it is equal to 0. So finally the answer is negative 8. And same thing, when I divide each term of this function with x and x cancel off. For this value of x, if I want to change to square root of x power 2, same thing, this limit x approaches negative infinity means x is equal to negative square root of x power 2. So I must change x becomes negative square root of x power 2. Then I combine the denominator becomes this, because I'm using the concept of index here. Then when I simplify, I get something like this. And when I substitute x with the negative infinity for the second time, I find that this is equal to 0. So finally the answer is negative 8. Now we try next question. Find the limit of this function as n approaches positive infinity. So for the first time, I substitute n with infinity. Then I find that the answer is infinity minus infinity. Infinity minus infinity is also another type of indeterminate form of limit. So means I'm going to use other method. And I found that n minus square root is conjugate with n plus square root. So now I divide the function with the conjugate. Now I simplify the numerator and I expand the numerator and I get negative 7n. And now after simplifying, I substitute the n with infinity for the second time. But this time I found that the answer is infinity over infinity. Still, it is the form of indeterminate of limit. So now for this time, I'm not going to multiply with the conjugate. Here I have two options. Here I'm going to factorize the n power 2. When I factorize the n power 2 here, now I get something inside the brackets here. Now I separate the square root of n power 2 and 1 plus 7n. As for square root of n power 2, we know that square root of n power 2 can be positive n or can be negative n. And since now we want to find n approaches positive infinity, so means square root of n power 2 is equal to positive n. Then we'll notice that n can be cancelled off. When cancel off the n, now we substitute n with the infinity for the third time. So 7 over infinity is 0. So finally, the answer is negative 7 over 2. And for this question, I have option 2 to find the limit for this part. Okay, now I decide to divide each term in this function with the highest power of n of the denominator. Notice that the highest power of n of the denominator is not n power 2 because n power 2 is under the square root. So, square root of n power 2 actually the highest power is n. So, means the highest power of the denominator is n. So now I divide each term with n. So 7n divided by 10, n can be cancelled off. This one, n over n can be cancelled off. As for this part, before I can cancel the n, I must change n becomes square root. So we know that n, when we change to square root, can be positive square root of n power 2, can be negative square root of n power 2. Since now we are finding the limit of n approaches positive infinity, so means n can be changed to positive square root of n power 2. Then after that, I combine this part and I simplify, then I'll get something like this. So, when I substitute the n with infinity for the third time, now finally, I'll get the answer is negative 7 over 2. Now let's try this question. Find the limit of this function as x approaches 1. So for the first time, I substitute x with 1. Now I find that the answer is 0 over 0. So this is indeterminate form of limit. So now I decide to use other method. Notice that square root of x minus 1 is conjugate with square root of x plus 1. But for this question, multiply with the conjugate square root of x plus 1 is not suitable because this method will not help you to find the answer. So not all the time multiply with conjugate set will help you to find the answer. Now since the conjugate set is not suitable, so now I'm going to use another method. That is, I'm going to use L'Hopital's rule. So remember, if you want to use L'Hopital's rule to find the limit, you must write out the formula. So to use L'Hopital's rule to find the limit, now I'm going to find the derivative of the numerator and the derivative of the denominator separately. So after differentiate, the derivative of the numerator is this one, and the derivative of the denominator is this one. So now I substitute the x with 1 for the second time. When I simplify, then I'll get the answer is 3. Now for the second method, I'm going to use substitution. That is, I try to substitute square root of x with u. So when u is equal to square root of x, so u power 2 is equal to x. When we substitute u with square root of x, then all the variable of x in the question must be replaced with u. Include the index here. So when x approaches 1, at the same time u approaches 1 also. So after that, now I can replace all the x with u. So now x power 2, since x is equal to u power 2, means x power 2 is u power 4. Square root of x replaced with u. Square root of x replaced with u. X approaches 1 replaced with u approaches 1. So now I factorize the u on the numerator. After factorize, I substitute u with 1 for the second time. I find that it is still 0 over 0. So means I'm going to use the second method to settle this problem. Maybe you can continue with L'Hopital's rule after this. And another option is I'm going to factorize u power 3 minus 1. By using the factor theorem that you have learned in Sem 1, so we find that one of the factor of u power 3 minus 1 is u minus 1. So then after that, using long division, I divide u power 3 minus 1 with u minus 1. Then I'll get a quotient as u power 2 plus u plus 1. So means u power 3 minus 1 is equal to the product of u minus 1 multiply u power 2 plus u plus 1. So now I notice that u minus 1 and u minus 1 can be cancelled off. Then after cancel off, I substitute u with 1 for the second time. Now I get the answer is equal to 3. Next question. Find the limit of this function as n approaches infinity. So for the first time when I substitute n with infinity, I found that the answer is infinity over infinity. That is one of the indeterminate form of limit. So now I'm going to use another method. For this question, conjugate set is not suitable. So now I'm going to apply one of the properties of the limit. That is, limit of square root of function f(x) is equal to square root of limit of f(x). So means I'm going to drag the limit into the square root. Now I'm going to find the limit of this rational function first. To find the limit, now I'm going to divide each term with the highest power of n of the denominator, that is n. So I divide each term with n, and when I simplify, I get something like this. Now I substitute the n with infinity for the second time. I find that 3 over n is 0, 5 over n is 0. So this one will get infinity. And square root of infinity is equal to infinity. So the value of limit is positive infinity. Next question. Find the limit of this function as x approaches infinity. First, when I first substitute value of x with infinity, e power infinity is equal to infinity. E power negative infinity is equal to 0. Now I get infinity over infinity it is an indeterminate form of limit. Now I'm going to use other method to find the value of limit. To find the value of the limit of this function, I need to cancel the term which costs infinity. Now the term which costs infinity is e power x. Now to cancel off the term e power x, here I have two options. First option is I can factorize the e power x from the numerator and also from the denominator. When I take out e power x, so here I will get 1. And for e power negative x, when I take out e power x, it becomes e power negative 2x. Then notice that I can cancel off the e power x here. Then after cancel off e power x, now I substitute the value of x with infinity for the second time. E power negative infinity is equal to 0. Now I get the answer for the limit is equal to 1. Then now I have the second option to cancel the e power x. Now I can divide each term in this function with e power x. That is the term which costs infinity. So e power x cancel, I get 1. Now e power negative x divided by e power x, I get e power negative 2x. When I substitute x with infinity, e power negative infinity is equal to 0. So now I get the value of the limit is equal to 1. Next question. Find the limit of this function as x approaches 1. So first, I substitute x with 1. When I substitute x with 1, 1 minus 1 is equal to 0. So e power 0 is 1. 1 minus 1 is 0. So the numerator is 0. And for denominator, when x substitute with 1, 1 minus 1 is 0. So e power 0 is 1. So 1 minus 1 is 0. So now I get 0 over 0. This is the indeterminate form of the limit. Now I'm going to use another method to find the limit. To find the limit of this function, so it seems like very complicated for this function, but actually when we look at the expression on the numerator, we found that we can simply factorize this expression by using the formula here, where a power 2 is the exponent here, b power 2 is equal to 1. So when we factorize the expression here, I'll get something like that. After factorize, notice that this part can be cancelled off. So when we cancel off and we substitute the value of x for the second time, now we get 1 minus 1 is 0. So e power 0 is equal to 1. So now the limit is equal to 2. Next question. Find the limit of this function as x approaches infinity. So first, when I substitute x with infinity, I'll get infinity over infinity. It is indeterminate form of limit. Now I'm going to use another method. Now according to logarithm law, ln x power 3 is equal to 3 multiply ln x. Then I'm going to divide each term in this function with the term which costs infinity, that is ln x. So the numerator 3 ln x divided by ln x is equal to 3. Then ln x plus 5 divided by ln x is equal to the expression below here. Then after that, I substitute the value of x with infinity for the second time. Now 5 over infinity is equal to 0. So now I get the answer for the limit for this function is equal to 3. Next question. Find the limit of this function as x approaches 0. So when I first substitute x with 0, so 0 plus 8 is 8. Cube root of 8 is 2. So 2 minus 2 is 0. So now I get 0 over 0. So it is indeterminate form of limit. Now I am going to use another method. Here I use substitution method, where I substitute cube root of x plus 8 with u. When u is equal to cube root of x plus 8, then u power 3 is equal to x plus 8. And x is equal to u power 3 minus 8. When we substitute the variable x with u, means all the variable x must be replaced with u, included the index here. So when x approaches 0, so we simply substitute x with 0. Now we find that u is approaching 2. Now I'm going to replace all the variable x with u. First, the cube root of x plus 8, I replace with u, and x replace with u power 3 minus 8. And x approaches 0, replace with u approaches 2. Now to find the limit for this function, you can use L'Hopital's rule. But here, I'm going to factorize the denominator. According to the factor theorem that you have learned in Sem 1, one of the factor of u power 3 minus 8 is u minus 2. So when I carry out long division to divide u power 3 minus 8 with the divisor u minus 2, then I'll get the quotient here. So that is u power 3 minus 8 is equal to u minus 2 multiplied with this quadratic. And notice that u minus 2 can be cancelled off. After cancelled u minus 2, now I substitute u with 2 and I find that the answer is equal to 1 over 12. So that's all for now. After trying so many questions, now I'm going to conclude that no any single method is suitable for all questions. So if you use one method that couldn't help you to find the answer, then continue trying different methods until you get the correct answer. So in order to master this topic, you should do a lot of practice. So, good to see you here and thanks for watching.